43 on page 283, I think it is. And this is f of x is continuous on the closed interval ab, and there exists at least one number c, which is between a and c, such that the integral from a to b of f of x is equal to one of these expressions. So this problem here looks a little bit like the mean value theorem. And it does relate to the mean value theorem, but it actually relates to it from the integral form. And so this is where we're going to start. So the average value formula is basically the mean value theorem from an integral perspective. Okay, so the average value formula looks like this. Okay, the average value of f of x is going to be the area under the curve divided by the interval width. Okay, so we have here the mean value theorem looks like this as well. So we have a mean value theorem is the average slope is equal to the instantaneous slope at some point in the interval a to c. And this is what this is alluding to. So if I take a look at the average value formula, well, here's the average value of this graph. So I have f of x in the interval a to b. That red line represents our average value, and we know that that average value must occur at some point. That line, the red line, must cross that black line at some point c in their interval from a to b. We're going to call that f of c. So if I take a look at this expression, I'm just going to rewrite the average value. We can say that the average value occurs at some point f of c, and it's going to look like this. Okay, so how does this connect to the mean value theorem? Well, if we take a look at the mean value theorem from the antiderivative perspective, we can say that instead of using f, I'm just going to use big F. Big F minus big F of b minus big F of a divided by the run is going to be equal to the slope at some point c. Well, if that's my big F, f would represent my slope function. So there's my mean value theorem when I use big F. And when I look at that numerator, really that's the change in the big F over b minus a. That's equal to f of c. Well, the change in f, I can rewrite the change in big F as the area under the derivative function f between a and b. And here then gives me my average value formula that looks exactly the same as this one here. So if I then want to solve for the expression that I'm looking for, that's what the question's asking for, the integral from a to b. If I'm looking for that expression, well, I just need to move this part with this part. So I end up with b minus a times f of c, and that's equal to my integral expression from a to b of f of x dx. And so the answer looks like it is going to be C.